Well, so let us solve a question from GATE 2019. That question number is 41, and this is basically from particle physics. That question, it is given that you have a low energy collision, and also it is mentioned that is S wave collision between what? Between pi plus and deuteron. So there's a low energy collision between pi plus meson with deuteron, and that is producing pair of proton. So basically, they ask you to calculate the relative angular momentum of these two protons in the unit of h cross that you have to calculate. That is a question. Okay. So it's a really interesting question. As you know, whenever your deuteron is interacting with pion, that will always be strong interaction because that will satisfy that conservation laws associated with strong interaction. You can check here. If you check the charge conservation for this particle, the charge is +1, and deuteron composed of a proton and a neutron, so it will have positive charge. So on charge +1, that will be 2, and proton that will be 2 unit of charge. Charge will be conserved. None of them is lepton here, so lepton number will be conserved. Here's the spin. Spin of this particle is how much? That is 0. However, the spin of deuteron is on. So on the left hand side, you will have net spin, that will be on. This side, you have a proton having a half spin. So if you take the vector sum, then you will get a half plus half, that will be on. So that will be matching with left hand side. So spin will be conserved. Now if you check that isospin, so the pi plus is having isospin value, that is on, but deuteron is having isospin 0. Because in a system, if you consider that the concept of isospin, that if you group that particle or hadrons having same mass, same spin, and same strangeness, and if you group, then if you define that isospin, you will get for deuteron, you will get isospin that will be 0. Okay, that we used to teach in class. So on the left hand side, you will get isospin on, and you know the proton is having half isospin, so half plus half, that will be on, that will be matching with left hand side. Similarly, third component of pi plus, that will be on, and it will have 0, so on plus 0, that will be on. This will be half plus half, that will be on. Strangeness, none of the particle is strange particle here, so strangeness will be conserved. So all conservation laws will be satisfied. So basically what I'm trying to say, this will be your strong interaction. And in strong interaction, what used to happen, the total parity of left hand side will be same as total parity of right hand side. Now how will define the total parity of left hand side? So that will be defined as minus on the power L, the relative angular momentum of left hand side, and then intrinsic parity of, if you take left hand side, so suppose I'm calculating that left hand side total parity. Okay, so this is the orbital part, minus on the power L. L is the relative angular momentum of this left hand side, and since it is given that you have S wave scattering, so obviously for S wave, that L will be 0. So this is called basically orbital part, and then intrinsic parity of pi plus and intrinsic parity of deuteron. Okay, so whenever we will conserve that parity, you have to keep in mind that parity is multiplicative in nature. तो जैसे हम चार्ज में क्या करते हैं, sum of the charge of this particle plus this particle, and that will be matching with sum of the charge of this particle plus this particle. But here, when we'll consider parity, we have to take the parity of this into parity of this, and of course we'll have orbital part also. Okay, so if you see, this will be minus on the power 0, that will be on, and you know that pi meson is a boson. Boson, so obviously for boson, that intrinsic parity for boson particle, that is -1. But you have to keep in mind, this student used to make confuse here, that deuteron Deuteron, if you see that deuteron, some of the proton plus some of the neutron plus some of the electron, that will be some even number. So basically it will be boson. But this is the exception for deuteron. Although it's a kind of bosonic particle, but still that deuteron is having even intrinsic parity. So this type of question is to ask many times, and student used to get confused about that intrinsic parity of a deuteron. Okay, so although deuteron is like a boson particle, but still it has intrinsic parity, that is +1. So this is all about your total parity of the left hand side. So that will be -1. Now, if you calculate the total parity of this product, you calculate total parity. So, of course, you will have some orbital part, that will be -1^L. Then intrinsic parity of proton. You have 2 protons, so you have to take intrinsic parity of both. So they are basically fermion. So fermion is having even parity, even intrinsic parity. So altogether, you will get total parity of the product, that will be -1^L. Okay, -1^L. So total parity of the reactant, that is -1^L, should be matching with product. This should be matching with this, because this is strong interaction. From here, I can clearly see that the possible values of L will be on 3, 5, and so on. Okay, so in the option you have on as well as 3 also. It's a multiple choice question है ना. तो यहाँ पे on भी 3 है, on भी given है and 3 भी given है. But this will be most probable. This will be the correct. Why? Because you know that every system want to stay in lowest energy configuration. So if you see that energy associated with L, so I will calculate that. That will be L square by something 2y, right? Or you can say that L into L plus 1 h cross square by 2y. Now, if you have a low L, it means you will have low energy, and that will be most favorable. Every system want to stay in lowest energy configuration. So although on 3 both are satisfying that conservation laws, but still L equals to 1 is having low energy. That's why this will be the correct option. Okay, so really interesting question. Based on that, you'll have many questions this kind of interaction. No? So every time what you have to do, just you have to conserve the parity and then you have to proceed. But one thing you have to keep in mind, that deuteron having intrinsic parity, that is +1. Okay, so here student used to make mistake. Okay, thank you.